Hello everyone, this is Hassan Ali. Today we are with another topic of CSWIP 3.2.2, that is radiographic RT films interpretation specifically. This is a supplementary exam, uh, and it contains first part is of MCQs, and the second part is of density plus sensitivity questions, that will be 10 questions, and the third part will be your RT film interpretation. Okay, now I have discussed density and sensitivity in my early lectures. Now I will discuss about the MCQs and RT film interpretation in this lecture. For the MCQs, there will be 20 MCQs in your exam, and you have to obtain 70% marks in this part to pass this portion of your exam. Okay, so uh, for preparation of MCQs of RT exam, you need to prepare from PCN level 2 book of RT. Okay, and as me section 5 RT portion only. Okay, and 3.2 and 3.1 RT portion. Okay, this will be your course outline for uh, solving MCQs portion of your exam. Okay, so uh, you will find some questions from PCN level 2 book. You will also find some conceptual questions from RT ASME section 5 book, and you will get some questions from 3.2 and 3.1 book from entity portion, uh, entity portions of these courses. Okay, so you will get 20 questions, and already I informed you that you have to obtain 70% marks in this portion. This is not so tough questions. These are not so tough questions, but you need to prepare yourself as much as you can. Secondly, if I talk about the RT interpretation, then there will be 6 films of ferrous materials, and you will be given 6 films, and for each film you will be given a report, and you will be given a report and one sketch. Okay, and the sketch will be like this. This will be a rough sketch in front of you. This is a weldment. This is the base metal. Okay, so in this sketch you need to mention the length of your RT film. For example, you have given this RT film in front of you. You will put that on the film viewer, and you will see the defects over it. There will be different defects. Maybe there will be arc strike, maybe there is a simple porosity, maybe there are some cluster porosity, maybe there are some burn throughs there. Okay, some undercuts are there, and lack of penetration is there. Okay, like this, if you see some defects there, so in your article, then you need to mention these all of these defects in your sketch. Okay, you will put scale here. you will find the overall length of this artifilm, and you will put here whatever is the length, 250 millimeter for example. And then you have seen a defect named arc strike. This is the arc strike. So you will put here the starting point of your arc strike from this portion is approximately 40 mm. Okay, so in your sketch you will just write here, you will put one here. Okay, and on the bottom side here I am showing this in next page. You will write one is what? One is the arc strike from the, and you will mention the datum line distance. The distance of arc strike is 40 millimeter, that is 40 millimeter distance, and the length of the arc strike, for example this length is will be measured, for example this length is 4 mm. So you will mention here length is 4 mm. Like this you will mention all of the defects here, 2, 3, 4, 5, whatever the defects are. One more example I will take. For example, I will talk about this cluster porosity. Okay, you will find the distance of this cluster porosity. For example, this distance is about 100 mm. Okay, for this cluster porosity you will mention the area, not the length, as you have mentioned here in arc strike scenario. You will tell the area of this arc strike. Okay, so you will mention here, for example this one is 2, you will write here here 2. Okay, so you will mention here 2 is your cluster porosity. Distance from the datum line is 100 mm, and area, you will find the area from your scale. Flexible scale will be given to you during exam, and you will write the area, for example 4 mm square or whatever it is. You will mention the area of the cluster porosity. Similarly you will mention other defects. For example this one is burned through. Okay, this one is burned through. You will find the distance from the datum line, and you will write here that 3 is the burn through, and distance from the bottom datum line is 150, and the length is this one. So this is a way to deal with the defects in the RT portion of your exam. You will be given 6 films, and you need to solve all the questions in a similar fashion. One more one or two things I need to tell you is that you will find some cracks during your interpretation, but you don't need to mention that this is a crack, because you need to say that it is susceptible to crack. It is susceptible to cracking, because if you write that it is a crack and in reality it is not a crack, so the examiner will not pass you in your exam. So if you will use the word susceptible and you say that UT is recommended, then it will be good for you. Okay, this is the most important tip for you for this exam. And secondly, you don't need to mention so much small defects in your parent metal. Okay, you need to mention only bold defects like arc strike, porosity, something like that. Okay, so if we talk about the defects of all of the defects, then I need to tell you that some defects will be shown by a dark color, and the other defects will be shown by light colors. Okay, what are the defects which will be shown by light colors? These will be defects which have higher densities. Okay, like excess penetration. Okay, tungsten inclusion. These are high density. Okay, uh, excess cap height. Okay, this will be shown light in your RT film, and spatter, because the thickness will become high, so it will be it will be shown light in your RT film during interpretation, and the other things will be shown dark, because the density, because the thickness will be low on that areas. For example, burn through, lack of penetration, lack of fusion, slag, arc strike, and because the thickness will be less there as compared to the thickness of the base metals, so these will be darker. Okay, and these are the most important defects. um, Now I need to tell you these defects in during artificial interpretation. For example, this is a weld bead. I'm zooming in. So if you say that this is a penetration, lack of penetration will only be in the center of the weld bead. Okay, it will not be here. It will not be here. It will be at least, at most, center of the weld bead. Okay, this will be lack of penetration. Okay, if you talk about lack of fusion will be near to the center. Okay, and it will be a straight line, a sharp straight line. It will be a sharp straight line, so it will not be on the center, so it will most probably be lack of fusion. What is a burn through? Burn through is that you have used a high amount of current. The welder has used a high amount of current, and the thickness has reduced there overall, so it will be dense in color, and it will be in a big size. So this one is a burn through. Okay, now if you talk about the undercuts will be like an nail impact. Undercuts may be on the root side also, in your root also. It may be there, but very less chances are there. But most probably these are found on the toes of the cap side. Okay. Next defects, if you discuss about slag may be anywhere. Slag is the inclusion of oxides during welding. Poor internal cleaning is also the main cause of slag inclusion. And other defects, if you talk about in GTAW, gas tungsten arc welding, so tungsten inclusion may be there, so it will be light in color. It can be anywhere, but it will be light in color. Okay, the other defects, excess penetration is there, So excess root penetration will be on the center, and it will also be on the uh, in light color. Okay, because the thickness has increased as compared to the base metal of the subject. Similarly, if the cap height is much more, then overall you will find a lighter area, and you can say that it is a excess cap height. In GMAW, if we talk about GMAW, then you will name slag as a silica inclusion. You will not say that it is a slag, you will say that it is a silica inclusion. Okay, because silica has more chances there. Silica is the major slag inclusion in GMAW process. So you need to see the process before interpretation in your report. In your given report before exam, you will be given 6 films and 6 reports as well. Okay, other defects, if we talk about R porosity, it will be a circular type defect, a very small defect, a pinhole type defect. Okay, similarly, if you find more than 3-4 pores there, then will be called cluster porosity. Okay, these are the most common weld defects in your weld bead area. If we talk about the base metal defects, then there are some chemically affected defects there, and other defects are, for example, arc strike. Arc strike, you know that when the welder is welding and the electrode touches the base metal, this is a base metal. It may be there, it may be over the bead. Okay, so this is the arc strike. It will be darker in color because the thickness is less as compared to the base metal. And the other things are there. Spatter, when spatter occurs because of high current. If the high current will be high, then the spatter will appear. It may appear over the bead, it may appear off the bead. Okay, so spatter are also the defects you can see there. It will be light in color because the height, the overall thickness has increased as compared to the base metal. Okay, and the most important thing of cracking that you will see, a crack will be a irregular shape. It will not be a straight line. It may be a crossing, like a transverse crack. Okay, or along the bead, which is called longitudinal crack. Okay, and it may be at the end of your weld bead, here or here. So it may be a star crack. You may have heard in your welding processes, star cracking. Similarly, these defects are planar defects, can not be um, as visible in RT as it can be seen by UT, because UT is good to see planar defects as compared to RT. Okay, and these are the most common defects, and these are the most common RT defects, and this will be your RT exam. MCQs, 20 MCQs will be there. 5 density, 5 questions from density, 5 questions from sensitivity, and 6 RT films